the Gene Schermer Instructional Building at Grays Harbor College. Conceived in pre-design phase as a new place for science, math, and art, or SMART, it then mixed in additional focus on the STEM fields of technology and engineering, and the resultant was a new STEAM facility. This is the gateway to campus, and it captures a spirit of place. The cloudy Aberdeen sky provides a sense of the gritty can-do community with a history and connection to its timber logging roots. Sustainable design concepts begin with a social aspect, to give this campus a lasting source of pride in education and a place that endures the test of time. The design starts with a master plan concept for a future hilltop green, organized around an axis that connects to views across the Chehalis River. Rotating from a north-south orientation due to a hillside behind the site, it also defines this spot as a bookend to the south of campus and facing the gateway at the north of campus. The twisting rotation also inspired a dynamic project metaphor, a logjam on a flowing river. The building concept has two parts, a tower and a podium. A 4-story tower holds faculty offices plus laboratory and studio spaces. It overlaps or interlocks with a podium, which is a partial basement space engaging the hillside. The classrooms are arranged as rocks in a stream, and the circulation between them implies movement and activity around and between these solids, creating a free-flowing space of learning activity. Shading strategies are used to manage solar gain while maximizing daylight. This includes an understanding of the adjacent landscape, the use of fixed shading devices on south glass, and tailoring the window size and configuration based on orientation. Larger ribbon windows are at the laboratories and studios facing north, while smaller punched windows with operable sections are at the faculty offices facing south. The Campus Gateway project celebrated rain flowing away from the site in a channel along a hill climb stair, but this new project takes another step to capture and celebrate the Aberdeen rain and use it to flush toilets, to reduce total potable consumption in concert with low water use plumbing fixtures. The rainwater tank sits just in front of the tower in the top view. The exterior cladding consists of high-performance glazing and opaque walls insulated in the stud cavity, plus a continuous layer of exterior insulation. This exists as rigid foam behind brick masonry walls, or as factory foamed metal panels above. Silver metal panels running horizontally, and colored panels running vertically. A planted roof system of gently rolling landscape mounds exists over the level 1 podium, to be used as both a campus amenity and also to reduce stormwater volume, to reduce heat island effects, and to provide increased roof insulation value. Rain gardens are also employed on the site for biofiltration before stormwater discharges to Lake Swannah to the east. The use of roof skylights along the center spine of the tower provide daylight to the middle of the floor plate at the upper 2 floors. The free-flowing activity of public areas picks up the logjam metaphor with a series of metal elements adrift in the terrazzo floor, as well as in a scattered pattern of light fixtures floating overhead. Wood wall cladding and wood ceilings with exposed concrete walls are used throughout. Concrete for its thermal mass and durability, wood for its warmth and its connection to local timber history. In major public areas, the concrete is cast with formwork that implies horizontal layers, perhaps influenced by water eroding the solid, as an expression of the flowing river design concept. Furthermore, salvaged material reuse has been employed. Glue laminated timber beams from existing campus buildings demolished for the site are repurposed for building items, including furniture and special interior wall finishes. Ground source heat pumps provide heating and cooling water to conditioned areas in the building, limiting the use of chiller and boiler equipment. A field of ground-coupled wells were drilled under the adjacent south parking area, and they provide a majority of the mechanical heating and cooling energy by using minimal pump energy to circulate a fluid medium that exchanges its energy with the earth. Labs are provided with VAV rooftop air handling units for heating, cooling, and exhaust. Office spaces use radiant floor heat and eliminate refrigerant-based cooling. Cooling is accomplished using natural ventilation with operable windows, ceiling fans, plus mass activation of the radiant floor with cool water. Classrooms are provided with chilled beams to provide heating and cooling. The collection of spaces in the podium are really the hub of flexible interaction and activity. In 2008, we started calling this the SMART building, Science, Math, and Art, but more recently the college has been calling it the STEM building. Well, to me, you cannot leave out the art and must at least combine them so that SMART plus STEM equals STEAM. The lower level podium spaces are provided with daylight via overhead skylights, with a coffered interior ceiling and light deflectors hung below to bounce light and illuminate the ceiling plane. Lighting controls automatically dim with the amount of daylight, and the skylight glass itself can be darkened with electronically tinted glass technology. The podium classrooms use active chilled beams to circulate water to units to radiantly heat and cool, and they limit system ductwork to the minimum required for ventilation air only. These are located as sidewall units around the edge of the daylight coffer above. The new 70,000 square foot building will provide spaces for students and faculty in the sciences, nursing, math, and art programs to interact with one another across disciplines. I am anticipating the interaction between classrooms and circulation areas abuzz and in motion, a place to see and be seen, but also a place to sense the light of day, even in a basement. Public art will play a large role in the character of the basement spaces. A ghost tree and reinterpreted forest canopy of colored glass leaves and pipe and cable branches hang in the round skylight overhead. Entitled Clearing, it changes with the various views of the Aberdeen sky, from bright sun to a veil of overcast clouds. Completed in 2015 as a new center for science, art, and technology on campus, the new STEAM building will create an environmental learning opportunity. It will be an enduring source of pride for students and the community, and perhaps will inspire student passions for discovery and innovation in a place where art overlaps with science.